These notes are on how to use formal charge assessments. Our target goal today is to calculate and use formal charges to determine if a structure is correct or incorrect. This is an extremely helpful tool when especially you have resonance structures. Remember, that is when we have more than one structure possible for a compound. So formal charges, the goal of them is to help us check to see if our structure is correct. Generally, the most energetically favorable structure is the one in which the formal charge on each atom is 0 or very near 0. So basically, this is a calculation that you are going to do. The difference is from geometry is that for formal charge, you calculate for every single atom. Sometimes atoms are identical and you don't have to calculate multiple times, you calculate once. So you're going to see that come up in the example. So there are some rules for assigning formal charges. Okay, the first couple of rules are this. In a molecule, the formal charge sum has to be 0. So if we have just a plain old molecule, H2SO4 is going to be our example, there's no charge on that. When we add them all up, it should equal 0. If you have a polyatomic ion group like SO4 with a -2, or in our examples here, NH4 with a plus charge, OH with a -1 charge, when you add up your formal charges at the end, the sum should equal the charge on the ion, so hence a +1 or a -1. Now, to find the formal charge for each atom, we're going to use the following formula. The formal charge is equal to the group number, that's the number of valence electrons. We find that by looking at the Roman numeral at the top of the periodic table, minus the number of bonds that the atom has, plus the number of unshared electrons. Now, this is different from geometry. We do not count electron domains, we're counting bonds. So this time a single bond is 1, a double bond is 2 bonds, a triple bond is 3 bonds. So again, it's not domains, it's bonds. Again, the group number is equal to the valence electrons, or the Roman numeral on the periodic table. Now, when this really comes in handy is when the several structures are possible for one molecule. When that happens, the most stable or best structure is the one with the lowest overall formal charge on each element. So in other words, the most zeros or those closest to 0. The most electronegative element should have a negative formal charge. This is an important one. So oftentimes you're going to encounter a couple of structures that seem similar. They seem to work out fine, and you have a hard time deciding. This is one of the key ones that's going to help you pick it out. You're going to have to use your electronegativities. The most electronegative element should have a negative formal charge. Now, one other thing, atoms that are bonded together should not have formal charges with the same sign. So two atoms should not have positive charges together if they're bonded to each other. All right, and structures where this happens are usually incorrect. So now we're going to try an example using H2SO4. So we're going to work our way through atom by atom. All right, we're going to start with the hydrogens. These two hydrogens are identical, so we really only need to calculate once. Again, our formula is the group number. Group number for hydrogen is 1. So it's 1 minus the number of bonds. Well, hydrogen only has one bond, plus the number of unshared electrons. Hydrogen doesn't have any. So our calculation will be 1 for the group number minus 1 bond plus 0. And that equals 0. 1 minus 1 is 0 times 2 hydrogen atoms, because I have one atom on the left and I have one atom on the right. So still my total charge is 0. We're going to repeat the same process for the rest. We have what I'm calling oxygen X and oxygen Y, and then sulfur. So the X's are on the X-axis, the Y is on the Y-axis, because these two oxygens are the same on the left and the right. The oxygen on the top and the bottom are the same. So for oxygen X, these guys on the side, again, group number is the Roman numeral, so it's 6 minus the number of bonds, 1, 2. Now, I'm talking about both atoms, but I only count one atom at a time, and then I'm going to multiply at the end. So 2 bonds for this oxygen plus 4 unshared electrons. So 6 minus 6 is equal to 0 times 2 oxygen atoms, that equals 0. Then we have oxygen Y, the oxygen on the top and the bottom. So for oxygen Y, we have 1 bond plus 6 unshared electrons. So that gives us a minus 1 charge. 6 minus 7 is minus 1 times 2 oxygen atoms is a minus 2. This is the important number though. The formal charge on each of those oxygens is a minus 2. The total is a minus 1. The total is a minus 2. But the individual formal charge is a minus 1. That's the number we need to pay attention to. Now, last atom for sulfur. Sulfur's in the center, also is in group 6. So it has 4 bonds and 0 unshared electrons. So 6 minus 4 plus 0 is equal to 2. And there's only one sulfur atom, so I get 2. And then we are going to total the whole thing together, and that is equal to 0. This is what we want. The whole structure is a neutral molecule, so we should, when we add up all of our formal charges, get a total of 0. Again, if it was a charged particle, something in brackets, then we would want our charge, or our total, to equal the charge on that. So we have two problems that we're going to work on in the homework, number 397, or on page 397, number 97, and then the worksheet, number 67, which is right on the next slide. Okay, so we are going to do one of each of the two problems together, starting with number 97. There are 8 structures. Yes, you do need to draw all 8 of those structures and then check the formal charges. And it says the central atom, I want you to do all of the atoms, not just the central atom. It's good practice. So here's our first structure, POCl3. A couple of these are ones that you've drawn already, so feel free to go back and look at your previous structures and see if it's something that you've already drawn instead of starting from scratch. So chlorine, there are 3 chlorines, all 3 are identical, so I only need to calculate this once. Chlorine is in group number 7. It has 1 bond and 6 unshared electrons, so 7 minus 1 plus 6 is 0. The formal charge for the oxygen here on the top is group number 6 minus, it has 1 bond plus 6 unshared electrons, so the same situation as the chlorine. So 6 minus 1 plus 6 is equal to a negative 1. And then last but not least, phosphorus is in group number 5. It has 4 bonds and no unshared electrons around the outside. So it has a plus 1. When we add this all together, we get 0, and that's the way it should be because there's no charge on this. When you get to letter B, you have a negative 2 charge. So when you total up, that should equal a negative 2, and then so on for the other molecules that you have there. So pause, work your way through the rest of those, and then we will proceed with the last question, which is number 67. It's a worksheet. Here's the other situation that you use formal charges for. When something can be drawn more than one way. For instance, Cl2O could be drawn as this first structure A or as this second structure B. Okay, so I guess we'll call it A number 1 and A number 2. So in those two structures, we need to make a decision. Which one is the best structure? Sometimes when you look at it, you might have your best guess. Other times you're not really sure how things are going to work out. So you do need to check it with formal charges and prove one way or another using your notes from the previous slides exactly what's happening and what is the best structure. So we'll start here with structure number 1. The 2 chlorines on the end are identical, so group 7 minus, they each have 1 bond, that's represented by the stick there, 6 unshared electrons, so 7 minus 7 is 0. We would multiply that by 2 because they're both the same. And then the oxygen in the center has 1, 2 bonds, and 4 unshared pairs of electrons, so 6 minus 6 is 0. Total is 0. So that number 1 tells you that the structure is good. Okay, now we want to compare it to the other structure. Chlorine, we'll start with this one on the end, again has 1 bond, 6 unshared electrons, so 7 minus 1 plus 6 is 0. Chlorine in the center has 2 bonds and 4 unshared, so 7 minus 2 plus 4 is 6, gives us a plus 1 charge. And then the oxygen over here on the end has 1 bond and 6 unshared electrons. So group 6 minus 1 plus 6 is equal to a -1 charge. So our total is equal to 0. So again, both of these structures work. They're both good. But now we go back and we look at our notes. Our notes tell us that the one that is best is the one with the lowest overall formal charges, or the most zeros. So based on what we see here, the one with the most zeros is the first structure. So this is the better of the two structures. You will have to prove this on the next test, showing your work which structure is the best. Now, if we had had charges for both of them and we basically had a +1 and a -1, again, we would go to the next rule, which says that you want the most electronegative atom to have the negative formal charge. So that would be, in this case, the oxygen should have the negative formal charge, okay? But again, zeros are better, so this is the better structure. But if we had something that was identical to this, but the +1 and the -1 were switched, then it would be the structure where the oxygen had the -1. But in our case, it's this one because this one has the most zeros. So that's really all there is to it. You have letter B and letter C that you will need to do the same thing. Next week we will be reviewing more and having other questions very similar to this that we will work on, and guarantee you will see one of those on the exam. Use your time wisely, get all that homework done, finish any other Chapter 8 homework that you have not completed already. The questions that are needed to be redone for the retake that you took on Wednesday are uploaded to you on Edmodo. So if you are interested in doing that retake, you could use your time today to work on that. Otherwise, finish any ACT practice from the link on the Edmodo post that I sent to you, and or pick up any of the extra ACT practice off the front desk. Have a great weekend. See you on Monday.